Hi, grade 9s. Welcome to another day in the life of a grade 9 math student. So, we're going to be moving on to 1.3, which is surface area today. 1.3 is a unit that requires patience, and it requires moving at a relatively slow pace so that you don't make any errors. It's really easy to make errors if you don't take your time on these. So I think I'm going to separate this out into 2 days worth of learning and a couple videos. When we're dealing with surface area, I always like to think about painting the outside of an object or putting carpet on the outside of the object or something like that. Surface means outside, so we only care about the shapes that are on the outside. We don't care about filling up the middle. At some point in your math career, you'll go through volume, and that deals with what's inside objects. But for now, we're just going to deal with painting the outside. So that always helps me. I thought it might be a good idea to go through a little bit of a review for 1.2, just to help some people out with the two-line method and also doing some Pythagoras. For the first quiz, there was an example where I want you to use the two-line method. So I want to make sure that that's as clear as possible before we move on. So let's just start with this one right here. It says use a benchmark to approximate to the nearest tenth, so to 1 decimal place. We could just do the, sort of quick and dirty estimation method where we say, well, 6.8 is close to 7. And the perfect squares that we know that are close to 7 are 4, which is 2 times 2, and 9, which is 3 times 3. So you kind of decide yourself, is it closer to 9 or is it closer to 4? Well, 7's closer to 9, so we'll use that. But it's not quite 9, so it's not going to be 3, so we might estimate it to be somewhat less than 3, maybe, 2.7 or something like that. But the more accurate way of estimating something like this is to get a piece of paper and do the two-line method. So in doing the two-line method, I've just put up a little square here. Again, it doesn't have to be perfectly accurate. You can sketch it out with your pencil, but try to follow along with me as I detail how we do this. So up here on the top, we always want to put what the number is. So we're going to put the number up here. And that's going to be, if we're at 6, we always want to start at the perfect square that's lower than it. So we know that the perfect square that's lower than 7 is 4. And we know that on the higher end, it's going to be 9. And our number is going to be somewhere in here. So what we want to do is we want to kind of find the midpoint and where 6.8 would appear if this was a number line. Let's see, 5, 6, 7, 8. Now this is kind of important. You want to make sure that you get some reasonably accurate reference points. So if I go from 4 to 9, that's a jump of 5, right? 5, 6, 7, 8, 9. So that's a jump of 5. Whoop. So if I cut that in half, I'm cutting that half in half and making, I've got to add 2.5 to this side. So in the middle, between 4 and 9 is 6.5. Okay? And that's just me finding the middle of an object, right? And you can do this. The easiest way to do this, I think, is something we probably did in grade 4. If you want to find the midpoint between two numbers, you can just add them together and divide by 2. So that equals 13 divided by 2, and 13 divided by 2 equals 6.5. So that way, it makes it easy to find out what the middle is. And if I'm going to put a middle on top, I should put a middle on the bottom. Okay, so now down here, we have to do the square roots of the numbers. Okay. So we know the square root of 4. We have that memorized. That's 2. We have the square root of 9 memorized. That's 3. Well, what's going to be right in the middle of 2 and 3? It's going to be 2.5. Okay, we don't need to do any math to know that. I mean, it should be relatively obvious to us. All right, let's go back up to the top part here. Now, where do you think that 6.8 would fit on this scale? Okay. We've got 6.5 right here, so it's going to be really close to 6.5. And so if this is 6.5, 7 would be somewhere around here, 8 would be somewhere around here, and 9. So I'm going to estimate that 6.8 is right about there. Okay, so now that you've decided where 6.8 fits on the top line, now you've just got to trace it down to the bottom line. Try to use as straight a line as you can. If this is 2.5 and this is 3, where do you think this point is right here? Now, if you need to, you can split this bottom section up too. Well, what do we know about what's exactly between 2.5 and 3? between 2.5 and 3 is going to be 2.75. So we know it's not going to be more than 2.75, but we know it has to be more than 2.5. So if we put this number down here, I'm going to actually revise my estimate, and I'm going to say the square root of 6.8 is about 2.6. Okay, so I think this is about 2.6. So what we did was we found where the original number fit on the top, and then we traced it down to our square root section and decided, well, if it's between these two numbers, it's probably about 2.6. Now, I'm going to put it in my calculator. I'm just going to see how accurate our guess was, or estimate was. So the square root of 6.8 is 2.607. So you can see without using a calculator, we got really close. Really close estimate using our benchmark method. Okay, let's move on to the next one here. All right, so we've got root 86 now. I'm just going to draw a square so I don't have to draw the two lines, because as we've all seen, I'm not I'm not great at drawing straight lines on this machine. All right, so here we go. Just draw myself a little square to get going. All right, let's look at the square root of 86, and let's decide what are the two numbers that are closest to 86 that we can use to sort of make a reference point. Okay, well, I'm going to start at 6. So 6 squared is 36. 7 squared is 49, 8 squared is 64, 9 squared is 81. Okay, well, 81 is close to 86. That's probably the best I'm going to do. So I'm going to start by taking square root of 81, sorry, not 9. And then in the middle, I'm going to put the 86 that we're looking for. And then we got to find one more number that's above. So we have a number that's below 86. We got to find the next closest number above. Well, this was 9 times 9. Okay, so what's 10 times 10? 100. That's obviously going to be the next number. Okay, so we know that this is 9. We just need to memorize that chart or have it handy so that we can figure these out quickly. And we know that the square root of 10, well, where does 86 fit between 81 and 100? Okay, well, midway between 81 and 100 is about 90, right? So 86 is going to be closer to 81. So it's got to be between 9 and 10, and it's going to be 9 decimal something. We know that much. And then as far as what we put on the 10th here, on the decimal portion, is it closer to 81 or is it closer to 100? Well, it's closer to 81. So let's make a quick estimate here of, let's go with 9.3, and we'll see how we do with that. Okay, so that's sort of the quick and dirty method. Now we're going to do the number line method. So we're going to put the numbers here, and we're going to put the square roots of the numbers down here. We decided that 81, okay, is the low end, and we also decided that 100 is the high end. So instead of going 81, 82, 83, 84, 85, 86, and trying to separate it out that way, I usually just try to find the midpoint. Does that look to be about the middle? Pretty close. And now we've got to decide what's in the middle between 81 and 100. Well, I could do an estimate of that, or we could just do what we did before. We could do 81 plus 100, divide it by 2 to find out what the midpoint is. So that's 181. Divide by 2, and what that's going to be is 90.5. So this middle point here is exactly 90.5. Let's go down to the bottom now. What's the square root of 81? We've already talked about this. It's 9. What's the square root of 100? We know it's 10. And once again, we know that the final square root for 86 is going to be somewhere between these two. If this is 90.5 up here, where is 86 going to fit between 81 and 90.5? Well, if I split this up into another half, what's midway between 81 and 90.5? Now, I'm not going to do the math again. You could do it, but it might take a little longer than we want it to take. So from 81 to 90.5 is about 10. So I'm going to take about 5 for this, and I'm just going to call this about 86. All right? So that's the number we're looking for. So if it's 86, we decide is kind of right in the middle between those two, and I track it down. It's not a very straight line, but I track it down to this line here. What's midway between 9 and 10? Well, we know the midpoint has to be about 9.5, or exactly 9.5. So now we're somewhere between 9 and 9.5. So we've narrowed it down to what the square root could be. And to me, it looks like this is pretty darn close between 9 and 9.5. So that's going to be at 9.25. It only asked us to do it to the nearest 10. So I'm going to estimate 9.3. Okay, so this time I got exactly the same answer as I did with the quick method, but now I'm more confident in it because when I drew the lines, as long as I drew my lines straight, which, as you can see, they're not perfect, our estimate should be pretty good. So the square root of 86 using this method, we got about 9.3. Let's check the answer on our calculator and see how close square root of 86 is. 9.27. So we're going to round 9.27 to 9.3, which means our estimate using both methods this time was extremely good, okay, with no calculator. Let's do one more. Okay, we're going to do 150 now. So 150, going to draw a rectangle to help us get going. Okay, I'm moving a little quicker now because we've done this several times already. 150. Just put that in the middle. What's the nearest perfect square to 150? Well, if we check our charts, 12 squared is 144, 13 squared is 169. So here's 144. That's going to be the closest on the low end. And on the high end, it's going to be 169. So this is 12. That's the square root of 144. This is 13. So we have to decide when we're doing this quick method, is it closer to 144 or 169? Well, to me, that's only 6 away, so I think it's closer to 144. So it's going to be 12 decimal, something closer to 144. Let's guess, or estimate. A guess is just a wild guess. An estimate should be reasonably accurate. Let's estimate 12.2, and we'll go down here and see how we did. So again, we put the numbers here, and then we're going to put the square roots here, square root of the numbers. So this is 144 on the low end. This is 169 on the high end. And I'll just go down and do the square roots right away because we know what they are. This is 12 and this is 13. All right, so let's find what is the midpoint between 169 and 144. By the way, you can use your calculator in this class. It doesn't bother me, but it is very important that you know how to do it on paper as well, because you won't always be allowed to have a calculator in your math class, although we all know the reality is you're always going to have a calculator in your pocket. It's mostly about learning how to think these things through as opposed to just punching numbers into a calculator. All right, so I'm going to use a calculator here. Why not? 169 plus 144 equals 313 divided by 2 equals 156.5. Okay, so the midpoint between those two numbers is 156.5. And as long as I put that line somewhere in the middle, it's 156.5. Let's track it down to the bottom. Okay, we don't need to do any math. We need to know that we already know this line is exactly halfway between 12 and 13. So that means this point right here is 12.5. Now we have to decide, where does 150 fit on the top? If this is 144 and this is 156, okay, that's a gap of about, that's a gap of, 8.5. So what we're going to do is we are going to, 8.5 is, so I'm just thinking out loud here, is 152. So 152 is kind of right here. So where's 150 going to be? It's going to be right about here. Okay. So I'm going to say to myself, using the line system and as much logic as I can muster, I think that when it comes to 144 and 156, 150 is going to be right about there. That's actually not accurate. I'm not sure what I was thinking. I'm going to go back. Sorry about that, folks. Must have had some mental math wrong. Okay. 150 is 6 away from 144, right? 144 plus 6 is going to be 150. And 156 minus 6 is going to be 150 as well. So it's actually right in the middle. I had it closer to 144, but it's actually right in the middle. So I always like to leave my mistakes in here just to show you that no matter how old you are, no matter how many times you've done this, you still make mistakes and learn from them. So here's 150, and what's exactly halfway between 12 and 12.5. It's actually 12.25. But again, we only want to estimate to one decimal place. So instead of 12.25, I'm going to write 12.3. So according to our benchmark, it's a little bit different than our quick method. We found out that 150, the square root of that is about, remember that means about, 12.3. All right, let's check the calculator and let's see what we get. 150, the square root of 150 is 12.24. We were so close, but we were actually a little bit closer on the estimate, the quick method, than we were on the bottom one. But in either case, we were within a tenth of the actual calculator answer. In fact, we were within 100 if we're talking about rounding. So very accurate. So please make sure that you've practiced a few of those, and you can just pick any number you want that's not a perfect square. It's easy to find questions to practice for these. Pythagoras. Here's our review on Pythagoras, okay? What do we need to know? We need to know where the right angle is. I didn't say that's the right angle, but we can look at the picture and we can say that's the one that's 90 degrees. And I always draw that arrow out from it. So this is C. I know this is C. Our formula, I'm going a little quicker because, again, there's another video that's fully dedicated to this. Our formula is a squared plus b squared equals c squared. It doesn't matter which one's a and b. It does matter which one's c. So a squared, I'm just going to make the 2. So that's going to be 2 squared plus the b is 4 squared equals the c, which we don't know what it is, so I have to leave it as c squared. Now we can just do some math, bed math, order of operations. We've got to do our math here. So 2 squared is 4. 4 squared is 16. Again, you really, really should memorize the squares up to 20. And if you're having trouble memorizing them, print them out on a piece of paper and have them handy because it'll just make your life so much easier. So we've decided that 4 plus 16 equals c squared. If we're solving for a variable, we want to have the variable on one side and we want to have the numbers on the other side. We've got a little bit more math to do because we've got 4 plus 16 and that equals 20. Again, don't stop here, okay? This is the big message from last time. You're not done. Don't stop here. We want to find out what c is. We don't want to find out what c squared is. So we've got c squared, and in order to turn a c squared into a c, we have to find the square root of it. And if we find the square root of one side, we have to find a square root of the other side. Remember, it's a balance beam. If you do something to one side, you've got to do something to the other side so that it balances out. So now this is a calculator question. I wouldn't make you estimate this, but we know that this side's going to be c because that's why we square rooted it. And the square root of 20, I can make an estimation, but I'm just going to punch it into my calculator. The square root of 20 is 4.47. Okay, let's just round that to a tenth. So we're just going to round that to 4.5. So they did give us units. Sorry, those are centimeters. So we found out that c equals 4.5 centimeters using Pythagoras. All right, next question. Hey, we've got a wire. And this was just more of like a real life problem. Let's say you've got a pole and you have to bring a wire down to the ground and it has to be 12 feet away from the bottom of the pole. We need to find out how long does this thing need to be? Well, that's pretty clearly the right angle there. So I'm going to draw my arrow out from that. C is already labeled C, so that's handy. Let's call this one A. Let's call this one B. A squared plus B squared equals C squared. On quizzes, on exams, assignments, anything that you're handing in, please, please, please show your work. You have to show your work because if you get the wrong answer, if you didn't show your work, I have no idea where you went wrong. So please get in the habit of not just writing down the answer, show me the work. It takes more time, but if you make a mistake, I can tell you and show you exactly where it is, and you won't make that mistake again. All right, what's our A? Our A is 16 feet, so I'm just going to put 16 squared plus our B, so that's 12 squared equals C squared. We don't know what C is again. Okay, 16 squared is 256. I know that from my memory, but remember, you can put a little cheat sheet beside your computer if you're having trouble memorizing it. 12 squared is 144, and that equals C squared. Just like the last one. Oh, sorry, don't want to skip a step. Let's do the math on this side. Okay, so 256 plus 144. You can also do it on the side if, I don't like making too many mistakes, so every once in a while, even if it's math I should do in my head, I just go over here and I do it. It's like, holy cow, that adds up perfectly to 400. Isn't that handy? Okay, so 400 equals C squared. To turn a C squared into a C, we got to take the square root of one side. And if we do something to one side, we have to do it to the other. And we end up with Well, that's a nice perfect square right there, 400. I know that that equals 20. And what is this, 20 feet? 20 feet equals C. So C equals 20 feet. Measuring in imperial units, must be an American telephone pole or something. So that's how you use Pythagoras to solve for C. I might put up one more little video about solving for something that isn't the hypotenuse. In fact, I'll just kind of jam that in here right now because there are some questions like that in your assignment. So I'm just going to draw a rough shape here and make up some dimensions, and we'll solve it. So let's say this is our triangle. Okay. This is our right angle. And let's say this time they give us the C. Okay, so they're going to give us, I'm just making a number up right now, 41. They gave us the C as 41, and they gave us the B as 11. So now we have to find out what this side is, okay? So I know that this one's C. I know that this one could be B, it could be A. It doesn't matter. I'll just make this one A. A squared plus B squared equals C squared. Now, we don't know what A is, so we have to leave it as A squared. We do know what B is. It's 11. So 11 squared. And we do know what C is 41 squared. And I picked a pretty big number there. Maybe I should have picked a smaller one, but we'll use our calculator anyway. A squared, we don't know what it is, so we got to leave it. 11 squared, I know for my chart, is 121. And I have no idea what 41 squared is, so I'm just going to type it into my calculator and find out that it is 41 squared. It's going to be a big number. 1,681. Oof, I did pick a big number. Sorry about that. 1,600, did I say 81? Yes, I did. Big number for C. It's okay. We're using our calculator for this one. All right, now our goal is to get the A squared by itself. So if I want to keep A squared here and alone, I have to get the 121 to the other side. So in order to do that, I have to subtract 121 from both sides. And we know that 121 minus 121 is 0. So I'm just going to cancel that up. On the other side, we've got 1681 minus 121. Well, that is going to be 15,156. Okay? So A squared equals 1560. In order to turn an A squared into an A, I have to apply the square root, and of course I have to do it to the other side. And we're left with A equals, I don't know what the square root of 1560 is, so I'm going to go square root 1560 on my calculator, and I'm going to get 39.5. Okay? Keep in mind this drawing is not to scale. So A equals 39.5. So this is just an example where this time they gave us C, they gave us the hypotenuse, so we had to do a little extra math to get this to the other side of the equation to solve for A squared. And the exact same thing would hold if they gave us this side and we had to solve for B. It's the same process. So hopefully that should help you a bit more with the estimating and using benchmarks to do non-perfect squares, and also solving for the sides of right-angled triangles with Pythagoras. Look for another video right away here, starting on 1.3, which is surface area.